Welcome back. So you just watched a video that talked a little bit about the gold foil experiment conducted by Rutherford. So this experiment, just to point out a few ideas, was done about 1909 and utilized what was referred to as alpha particles. Now, a couple key things that we should understand about alpha particles is that they are relatively heavy, and they have a positive charge. So, as outlined in the experiment, Rutherford set up his experiment trying to support the plum pudding model. And so what he envisioned would happen is that as the alpha particles were directed at the atom, that all of the alpha particles would pass directly through the atom, ending up on the other side in his development, on his development film. Because, simply put, nothing in the atom would be massive enough to stop these heavy alpha particles. Now, of course, the surprising results here were that a small percentage of alpha particles bounced back. And some alpha particles also were deflected. Now, after repeating this several times, Rutherford had to acknowledge that there was something else going on. And so what he basically did was developed his nuclear model of the atom. And this is right around 1910, 1911. So just within a couple years of what's going on here. And so the tenets of this model essentially are that he said that the positive charge of the atom and its mass, so the positive charge and the large percent of the mass was located in a small, dense area at the center of the atom, which he labeled as the nucleus. Now, furthermore, the negative electrons were scattered around the nucleus. So, because most of the alpha particles did, as anticipated, pass directly through, it was only these small percentages that were either bounced back, like they had hit something very massive, or were deflected. So, how did he sort of go on to explain this? Well, by putting all of the positive charge and the vast majority of the mass in this very small, dense area, he could account for a small percentage of the alpha particles encountering something that would be massive enough that would cause it to bounce back, that would stop it, in other words. So this became the nucleus. And the fact that the nucleus was positively charged would allow the positively charged alpha particles, if they were passing close to the nucleus, to be repelled because of the same charge. So the idea being here that if we think about the alpha particles going through here, most of them, would pass directly through. A few of them would hit the nucleus and bounce back. Right? And then some of them, a few of them, would pass close enough to the positive nucleus without hitting it that they might be deflected off at some angle here. And so, based on these results, this is what he came up with. Right? And so, we still have the positive charge balanced with the negative charge, right? But just all that positive charge is now isolated in the nucleus, and we have these negative electrons scattered around, and the majority of the atom is still empty space, if you were. Now, the other big contribution that Rutherford made was around the same time, based on this experiment and others. He labeled positive particles within the nucleus as what we now know as protons. So, within this nucleus, the positive particles are these protons. So now we have a picture of the atom that's starting to come together, right? We have these positive protons isolated within this small area called the nucleus. We have the negatively charged electrons existing around the nucleus. All right. So at this point, we have a pretty good picture of the atom. You're going to watch one more video here looking at the discovery of the neutron, which came quite a few years later. And then I'll come back and we'll kind of summarize the major points leading up to what we consider the modern atom.